Hi, my name's Joanne.
And I'm Nicola, and this is our group project where we've combined shaders. In this video we will demonstrate the shaded effects we managed to come up with during the time spent on the project and how we achieved them. Hello, my name is Nicola and I will briefly show my reflection and refraction techniques. For more details on these effects, please see my previous video link in the description. The cube on the screen will now display reflection, refraction and both combined, but now with a coloured water texture added. This demonstrates how reflection and refraction techniques create the building blocks for what can become a shaded effect that creates a water-like substance. The effect now demonstrated is normal mapping. Using a normal map texture and a specular map texture, we can use lighting equations in our shader to make the 2D surface of the cube appear to have depth. This effect looks best when applied to textures such as bricks, but we will stay with the theme of water for now. Again, we show reflection, refraction and both combined, but this time with normal mapping added. To further show the difference normal mapping makes, the program will show the cube displayed only with the coloured water texture applied, then followed by the normal mapping.
Hey, Joanne here. In the last video I made, for those who haven't seen it, there's a link in the video description. I showcased the first shader that I'd been working on. This video incorporates both versions of that shader, when the first strands are all the same length, and then when the first strands are all differing lengths. For a more in-depth look into how I created this specific shader, check out my other video. This time around, I've collaborated with Nicola to showcase both our previous shaders and the new ones we've created in the one video. We both programmed these shaders again in C++ with OpenGL and GLSL. This time around I've chosen to tackle cel shading. Like most shaders, there are several techniques that will get you to the desired effect. The first step to creating my cel shader is to create a per pixel lighting shader. This is when all light calculations are done in the fragment shader and where all lighting and colour is applied to each pixel individually, giving a much smoother lighting overall upon the object's mesh. From a per pixel lighting shader, cel shading isn't too much of a leap. Adding a diffuse and specular factor that changes output colour can help you achieve this. The diffuse factor is calculated using the dot product of the ice-based normal and the light normal. The factor helps create the individual areas of colour. As can be seen, there are three main shades of the one colour that help produce the cel shaded image. These are created using simple if functions, changing the colour depending on the value calculated. The specular factor is calculated using the dot product of the ice-based normal and the normalisation of the light normal. This factor, used with the step function, helps give each area of the colour an overall shininess.
And that's our video. Hopefully you enjoyed it and you can see that shaders can make some pretty cool effects.
The rest of the video will show the different outputs the shader can have, with a small annotation briefly showing the type of shader components used to create that particular effect. Both Nicola and I will have videos to come in the near future, so why don't you subscribe to our channels, the links in which can be found in the video's description. Hope you enjoyed the video. Any questions about the techniques used in the video, just send either myself or Nicola a message. Bye for now.